Hi, everyone. My name is Nilam Ruparelia. I'm from Microchip. I'm responsible for Edge AI market development and solutions. And today, I'm very excited to talk about the real solutions for real-world problems for Edge AI. I really like what George said, which is to not choose hardware without understanding the software. But the reverse is also very true. Do not choose software without completely understanding all aspects of hardware. So many times in Edge AI, we see people want to start something that's easy to use software because guess what? The AI responsibility is given to a software engineer, and software engineer knows certain existing software, GPU-based or whatever environment, and just starts proof of concept. And a lot of things gets missed out after proof of concept to taking it actually to reality. So some of that is what we are going to talk about. OK, so maybe you are familiar with Microchip, but if you're not, we're a broad semiconductor company, and we operate with pretty much all kinds of different market segments. Factory, agriculture, industrial, medical, building, power tools, defense space, variety of different market segments. We see Edge AI use cases today pretty much everywhere. So Edge AI is no longer future in the coming, it's happening today, and all kinds of use cases are happening. Whether it's robotics, imaging, anti-kickback in the power tools, sports and fitness, people want to track not just your heartbeats or number of steps, but actually what's happening if you're a sportsman on specific action you take and every specific play you have in NFL, et cetera, right? So all of those things are actually happening today. We categorize them into three different buckets. Smart embedded vision, where applications like machine vision, medical imaging, surveillance security, that's being implemented. Human-machine interface. So we talk about keyword spotting, we talk about large language models. All of those things are happening in Edge today, recognizing gesture and then supporting either it's a senior care application or in a retail application on what the person is trying to do. And last but not least, actually probably very high value, is sensor analytics. So you probably hear a lot about AI, TOPS, and high performance. A lot of Edge AI value will actually come from low performance, slow sensor devices. And I think with Things community here, with Arduino and LoRa community, you recognize this a lot better than many others. But the sensors which allow you to do predictive maintenance is where there's a much higher value that's coming in. OK, so I think we all understand on why include AI at the edge. There are lots of benefits on latency, privacy, cost, et cetera. But there are other considerations. When you start implementing AI model or software aspect of it, one of the big challenges that people come across is data. What is the data? In order to create a good model, high performance, high accuracy, you do have to have good quality data. And those data, unlike the large language model, not available on the internet, right? If you're doing predictive maintenance on a motor, you actually have to have some motor observation and data coming from those things. The other aspect is on-device learning and personalization. How do you update your model and then re-update your model as it learns from different places in different deployment? We talked a lot about security earlier today, so I think that's very obvious. This one is a lot less talked about, is multimodal fusion. So a lot of times AI is just thought about as a image or picture-based processing. But reality is if you put an AI in an industrial environment with multiple sensors like temperature, pressure, et cetera, you can find a much better outcome with multimodal sensor application. And then obviously the standard model activities, which you have to optimize the model, and then at the end you have to have the energy-aware architecture, right? So all of these things come into play in order to implement a successful Edge AI application. It's not about one thing this way or one thing that way. You have to go through all of these things. Couple of use case examples that we come across quite a few times. I talked about predictive maintenance before. A lot of times predictive maintenance has been in the past, heuristic-based predictive maintenance. It's just timer-based, right? If you have a car, you drive it 3,000 miles, hey, it's time for oil change. It's very inefficient. How about a model that actually senses the actual usage of engine in variety of different conditions and tells me whether it's a 3,000 mile I need to change the oil, or it's 5,000 miles or 2,000 miles. And that's really the concept here, whether it's a motor or it's a pump or it's something else. Applying multi-dimensional, multi-sensor fusion like vibration, temperature, audio gives you much better reliability of the model. Also provides you high cost efficiency and operational efficiency because you cover the aspect of wear and tear and maintenance upfront with multimodal. Another application we see quite often is about audio application. So of course hey Alexa, hey Siri kind of voice command has been very prevalent in the industry, and you can see a lot of application of this into automotive and other places as well. But if you realize, a lot of this has been half successful, right? Outside of your phone, even in your phone, the success rate of audio applications is not that high. And that is all can change with AI-based audio applications. And by the way, audio is not just for voice interaction. Anomaly detection is another one, right? If there's a water leaking and there's a dripping, you can also sense it with audio. It's not just about you need a humidity sensor there. And then, of course, sound classification, which is mostly about security application, the gunshot detection, glass breaking, some other noise. These are very common applications based on audio and very high-value Edge AI applications that we see. But what is critical here is to make sure this audio processing happens locally. If you're forced to process this audio and plug it up in the cloud, then many times it depends on cloud connectivity and defeats the purpose. Also, you want real-time responsiveness with high reliability, interactive actions, and personalization. Specifically, when you're looking at voice command-based approach where, hey, you want to build a solution that enables, hey Honda, open the door versus some other voice application. You also want programmability of those voice commands. So all of these aspects play a big role in getting right Edge AI implementation done. Therefore, the key here is really implementing AI into compact form factor, but the definition of the solution needs to be a lot more comprehensive. And of course, these were just two of the multiple use cases we have seen. There are many, many other use cases we see. In fact, I like to say this is a 1,000 beachfront war. And as we see at Microchip, this is over next 5, 10, 15 years deployment cycle. As people keep coming up with variety of different use cases, you kind of find variety of ways of applying AI models on the edge. Some of the additional use cases mentioned here is battery health, facility monitoring. Facial recognition is very common, but again, in EMEA, there is a concern about the laws about facial recognition, so you have to be careful. You can actually find solutions that will not recognize your face, even with camera, will keep your image inside the camera and still allow you to monitor people movement within a retail store to find out how many people are actually going into which aisle, at what time of the day, and so on. So privacy-aware, privacy-controlled face recognition is what's important. Orientation detection, if you're talking about a senior person care, putting a vest like this and put an orientation detection is a very, very, very useful use case where if something happens to the person and falls down, or the person is in remote location, some technician is going out on a telephone pillar and fell down, trigger a alarm condition to go for help for that. That's a very useful use case. Pause detection, driver monitoring, keyword spotting. So we see all of these kinds of use cases. So Edge AI is happening. As long as you design it right, it actually is very happening today. But once you think of use case and AI models and software hardware implementation, most often you'll end up onto a device that either gives you high, easy-to-use software or a device that talks about high NPU, hundreds of TOPS, etc. More often than not, that is less important. What is more important is to make sure the product you end up making at the end of the day also supports what is required in your end application environment. So for example, you need to build a product that's battery-based. You cannot really design something that is going to consume the battery, needs a fan on top of it, even though it has 10 TOPS. That is just a non-starter, right? It's just very simple. But it's very hard to find right solutions to actually implement all those criteria. The other example we come across quite often is, hey, I built an Edge AI solution, but my chip supplier is now end-of-lifing. Why? Oh, I'm an agriculture business, and I need supply. I need 2 years to prove out the solution, and then I need supply for 10 years. But the chip supplier I chose comes from non-industrial background, and their life cycle of product is much faster. This is a very common situation that's happening in the industry today. So you have to keep in mind life cycle management. Cost, obviously, they're generally in most people's mind, but it's not just cost of the software or the chip, it's the cost of the overall solution that matters. The other thing is learning curve. If you've got to learn everything yourself, then you're going to get a lot longer to build it. If you can use the supplier's ability to help you with building the solution, then it gets much faster there. And then obviously power consumption and support. So how do we address this? So Microchip is one of very few companies that actually has the entire toolkit put together. We offer microcontrollers, microprocessors, FPGAs from 8-bit to 64-bit. They are not into hundreds of TOPS, but they are into GOPS and milliops, but they are all very strong implementing Edge AI today. And we are able to implement most of the use cases we talked to you about in low power, small form factor, very compact chips in a low cost solutions today. You don't need extremely high-end solution to solve predictive maintenance type of problem. We actually have more than covered with variety of products available today. And it's not just that we have the silicon. We bring expertise in Edge AI and also technologies around it: security, motor control, connectivity, power management, and sensor. So when you work with Microchip, you actually find the whole thing from one place. It is also our own solutions as well as the network of partners and service providers, supply longevity, etc. Now, of course, the toolkit, we support Yocto, we support Onyx-based software toolkit. We have our own MPLab ML, which is a ML toolkit, as well as we work with third-party toolkits like Edge Impulse that were here before. And last but not least, we do have hardware toolkits, security devices, and probably most important, local support available for this topic in most of the markets we operate with. So that's my last slide, and thank you very much for your attention.
Thank you, Nilam.